Hello children, let us start chapter number 15 and that is electrostatics. First we will understand basic terms. In chemistry we have studied that there are three fundamental particles, electrons, protons and neutrons. They are part of an atom. Because of their mass, these particles attract each other by gravitational forces. Now let us understand electric force. Suppose there are two electrons kept at points A and B. The distance between them is 1 centimeter. Because of their mass, they attract each other by the gravitational force. We can calculate the magnitude of gravitational force by the formula Fg is equal to G m1 m2 upon r square, where G is gravitational constant, m1 is equal to m2 is equal to mass of an electron, and r is the distance between them. So gravitational force of attraction comes out to be 5.5 into 10 to power minus 67 Newton. Whereas experimentally it is found that these two electrons repel each other by a force of 2.3 into 10 to power minus 24 Newton. You can clearly see that force of attraction is much smaller than force of repulsion. This extra force is called as electric force. Now let us understand charge. Property of an electron which is responsible for the electric force is called charge. Just as the masses are responsible for the gravitational force, charges are responsible for the electric force. Let us understand types of charges. First, let us see these two experimental observations. Observation number 1. Charge on an electron repels the charge on another electron, but attracts the charge on a proton. Observation number 2, if we pack a proton and an electron together in a small volume, the combination does not attract or repel another electron or proton. The net charge on an electron-proton system seems to be 0. Now let us see these two important points. Point number 1, we arbitrarily call the charge on a proton as positive and that on an electron as negative. This is purely a convention. Point number 2, charge is a basic property associated with the elementary particles. The SI unit of charge is Coulomb and it is abbreviated as capital C. Now let us talk about properties of charges. There are many properties of charges, but we will talk only about two. Charge is quantized and charge is conserved. First property is charge is quantized. It means charge on any object is always an integral multiple of E and can be changed only in steps of E. For example, suppose if an object contains n1 protons and n2 electrons, then net charge on the object will be n1 into E plus n2 into minus E. Charge on the protons is considered to be positive and charge on the electrons is considered to be negative. So net charge on the object will be n1 minus n2 into E. Second property is charge is conserved. The charge on an isolated system is conserved. It is possible to create or destroy charged particles, but it is not possible to create or destroy net charge. Now let us understand induction. Suppose this is a glass rod and this is a silk cloth. When glass rod is rubbed with silk cloth, there are few electrons that get transferred from glass rod to silk cloth. So glass rod becomes donor of electrons and silk cloth becomes receiver of electrons. As a result, glass rod becomes positively charged and silk cloth becomes negatively charged. When this positively charged glass rod is brought closer to the pieces of paper, then pieces of paper get attracted towards the glass rod. In normal conditions, electrons are uniformly distributed over the surface of papers. When positively charged glass rod is brought closer to the papers, then there are some electrons on the paper that shift towards the glass rod. As a result, there are more number of electrons towards the near end as compared to farther end. So such a redistribution of charges in a material body due to the presence of nearby charged body is called as induction. Now let us understand Coulomb's law. Suppose Q1 and Q2 are two charged particles separated by a distance r. then force exerted by one charged particle on the other is given by the formula F is equal to k q1 q2 upon r square, where k is constant whose value is 8.98755 into 10 to power 9 Newton meter square per Coulomb square. It is approximated as 9 into 10 to power 9 Newton meter square per Coulomb square. K is often represented as 1 by 4 pi epsilon 0, where epsilon 0 is called permittivity of free space. Suppose Q1 is force exerting charged particle and Q2 is force experiencing charged particle. Then this formula can be represented in vector form as vector F is equal to k q1 q2 upon rq into vector r. Vector r is position vector from force exerting charged particle to force experiencing charged particle. Direction of vector F is same as direction of vector r. If these two charged particles are of opposite sign, then force will be attractive force. And if they are of same sign, then force will be repulsive force. Let us see a couple of questions based on Coulomb's law. First question, a charge capital Q is to be divided on two objects. What should be the values of the charges on the objects so that the force between the objects can be maximum? Suppose charge on one object is small q. So the charge on other object will be capital Q minus small q. Suppose the distance between them is small r. So force exerted by one charged particle on the other is given by the formula F is equal to 1 by 4 pi epsilon 0 q1 q2 upon r square. Here q1 is small q and q2 is capital Q minus small q. It is given that force has to be maximum. So we will apply maxima condition. And maxima condition will be df by dq is equal to 0 and d square f upon dq square is less than 0. When we do df by dq is equal to 0, we get small q is equal to capital Q upon 2. That means charge should be divided equally on both the objects. Second question, two particles each having a mass of 5 gram and charge 1.0 into 10 to power minus 7 Coulomb stay in limiting equilibrium on a horizontal table with a separation of 10 centimeter between them. The coefficient of friction between each particle and the table is the same. Find the value of this coefficient. Suppose this is the table. These two are charged particles which are identical. Their mass is given as 5 gram and charge Q is given as 1.0 into 10 to power minus 7 Coulomb. They are separated by a distance of 10 centimeter. Since these two charged particles are identical, so we can draw FBD of any of them. Suppose this is the FBD of this charged particle. Its weight works vertically downwards. N is the normal reaction applied by the table surface which works vertically upwards. These two charged particles are positive. So force will be repulsive force between them. So Fe represents repulsive force. Since particle is moving in this direction, so friction force will be in opposite direction. At limiting equilibrium, we will equate horizontal forces with horizontal forces and vertical forces with vertical forces. That means Fe is equal to F, suppose this is equation number 1, and N is equal to mg, suppose this is equation number 2. Fe is given by the formula 1 by 4 pi epsilon 0 q1 q2 upon r square. Q1 is equal to Q2 is equal to 1.0 into 10 to power minus 7 Coulomb. R is given as 10 centimeter, that is 0.1 meter. So F is equal to 9 into 10 to power minus 3 Newton. Friction force F is equal to mu into N and N is equal to mg. So friction force F is equal to mu mg. Value of m is given as 5 gram. That means 5 into 10 to power minus 3 kg. G we can take as 9.8 meter per second square. So F is equal to 4.9 into 10 to power minus 2 mu Newton. Now we can equate Fe with F. So 9 into 10 to power minus 3 is equal to 4.9 into 10 to power minus 2 mu. This gives the value of mu as 0.18. In the next video, we will see electric field and electric potential. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.